Hello! Today, let us further explore the atomic structure and discuss the nature of chemical elements. The concept of nuclide proves applicable to elements, allowing us to better understand their properties and behavior. But Nuclides is a very broad concept which can be divided into a number of parameters. So first of all, Nuclides can be different chemical elements. Different chemical elements. For example, it could be carbon, which is number 6 and has a mass of 12. Or for example, the element oxygen, which has the number 8 and has, for example, an isotope of 16. Or for example, calcium, which has an ordinal atomic number of 20 and might have a mass of 40. Then it turns out that these are nuclides of different chemical elements, and they have each of these elements a certain composition of the nucleus and electrons, that is, a certain number of these particles. The second kind is called isotopes. Isotopes are varieties of the same chemical element, and as we usually cite, here we have necessarily the element hydrogen, which has an isotope that has an atomic number of 1 and a mass of 1. That isotope is called protium. And we can easily calculate that this atom has 1 proton, no neutrons, and 1 electron. But there is an isotope of hydrogen that has atomic number 1 and mass 2. Such an isotope is sometimes shown by the letter D, which stands for a type of deuterium. Such an isotope has 1 neutron, 1 more neutron than protium, and its proton and electron particles are the same with them. That is, there is absolute identity between these particles in terms of protons and electrons. Now there is another isotope of hydrogen which has an atomic number of 1 but a mass of 3. Such an isotope is sometimes designated by the letter T. Such a variety is the element 3. And that's the heaviest hydrogen. These are the natural isotopes of hydrogen, with protium being the most abundant in nature, and deuterium the third is found in smaller quantities. Then what will these particles, these isotopes, have the same number? They would have the same number of protons and electrons and the charge of the nucleus, but different, that is, they'll have different atomic masses and numbers of neutrons. In this case, the ratio of the number of neutrons to protons, if it exceeds the ratio of 1.2, then such isotopes become unstable, or they are called unstable. Such particles, such isotopes can be included in nuclear processes, due to which new chemical elements are formed. Now there is another variety called isobars. What are isobars? Let us give the following example. This is the element radium, which has the number 88 and mass 288. Its isobar will be, for example, the element actinium, which has the number 89, but it also has the isotope 228. Or, for example, thorium, which has the number 90, but it has the isotope 288. From this, it is easy to see that the isobars will necessarily have the same relative atomic mass, i.e. the AP for these elements is the same, although they are different elements. And then there is a kind of nuclides called isotones. To give an example, it can be nitrogen with its atomic number 7 and, for example, with mass 15, and, for example, oxygen, which has number 8 and it has isotope 16. If we count the neutron content of each of these particles, it's 8 for nitrogen. And for oxygen, it will also have a total of 8 particles. Consequently, isotones can be defined as distinct nuclides that possess the precise identical number of neutrons. It is important to note that while various characteristics have been mentioned, we will frequently focus on isotopes due to their substantial practical applications. In addition, we will explore diverse chemical elements such as oxygen and carbon, which are crucial components in the field of chemistry. Lastly, my intention is to illustrate how we can effectively determine the number of particles within each of these elements. To exemplify this process, let us take into consideration the element calcium. This particular element serves as an illustrative example. Its atomic number is 20 and its mass is 40. If we want to write down briefly how many particles are in this atom, we can write it down like this. Then the protons this element will have, according to its ordinal number or atomic number, will be 20. Its neutrons will be 40 minus 20, also 20, and the electrons around the nucleus will, according to its serial number and the number of protons, also be 20. I should add that this isotope will be very strong, because if the number of protons and neutrons are the same or the ratio between them is 1 to 1, such isotopes are very strong. In addition to this, a wonderful thing like an even number of protons and neutrons plays an important role. Such numbers are called magic numbers for these elements. It's really a very important characteristic. And let's take an example with a large sequence number, for example, iron. It has an atomic number of 26. And let's take its isotope 56. Then how many protons would it have? It would have 26 protons. It would have 56 neutrons minus 26, 30, and it would have 26 electrons. What I have diagrammed below is called the composition of an atom, in which we list protons, neutrons, and electrons. Goodbye.